Hello, good evening. I'd like to do something on the stormwater layout plan and the long section. Okay, so this one is for the DE6102, the engineering projects. Okay, um, so I've done the the road layout plan already. Okay, so this is the road layout plan for the parcel 221. Okay, so um your scheme plan will be different from this. Okay, so this one is alternative scheme plans. So I'm going to put the stormwater pipes. Okay, so along um the verge of the road. Okay, so in this case, um the stormwater pipe is going to discharge into this concrete drain. Can you see the green color one? This is 900 concrete drain. So we're going to discharge um into that concrete drain. So there we will have to have the main this stormwater pipes running along the rod one. We need to have one and jaw one as well, and the rod two. Rod two, I think um, we can just do one. Okay, if sometime we if there's too many lots, a lot of lots, probably you can do um, one stormwater pipes on each side of the rod. So if this one only the other side only have five, so we can just do the pipes. We just provide the connector from this the stormwater pipes along the road reserve and then connect to the lots. Okay, so I think the rod two we just provide one. Okay, so because if it's many lots. Okay, so it's a big housing estate. We got 20, 30 lots. So probably you will have provide the stormwater pipe on each side. Okay. The draw two probably just one stormwater pipe. Besides the stormwater pipe, we need to provide those the manhole as well. The manhole the manhole is to connect all the discharge from the catch pit and from the lots as well. The lots mainly is the gutter, the water from the roof. Okay, so um, the water from the roof, from the rod, um, from the surface water, they will go into the catch pit, and catch pit will go into the manhole. So um, I just showed where's the catch pit. The um, okay, these are the catch pit along the rod. Um, at the edge of the rod. So the water will go into the catch pit from the rod surface, and also from the um, on the surface water. Some of the water they will go to the rod and then go into the catch pit. So there's the catch pit along at the edge of the rod. So it could be at a certain regular interval. It could be like um, 30 meter. It could be 50 meter, depending on I think the amount of the the rainfall intensity of that area. Okay, certain places which has not much rain, probably you don't have the interval probably will be further away. The interval will be bigger. Whereas some places, for example, in the west coast of South Island, you got plenty of rain. Probably you need the catch pit to be more costly space. Okay, so these are catch pit, and then the manhole is this is the pipes. The so this one is quite it can be quite deep. The manhole, this one is a precast manhole. The Hume, New Zealand. So the um water from this one whenever um you have a change of direction, you need to provide manhole. Okay, see inside the manhole, you see the pipes they can when they join the pipes, the from different um, lines, the stormwater pipe, they need to join at the stormwater pipe. Sorry, join at the manhole. Okay, even the catch pit, the water will be discharged into the manhole as well. Okay, so um, the manhole, it could be heavy duty or it could be light duty. I think at the moment, I think we just put the manhole at the grass verge, at the verge, or it could be under the footpath as well. But I think we at the moment we are not going to put under the rod. Yes, I think some of the covers, it could be heavy duty. Heavy duty, they could be put um on the rod. Okay, so it can is able to carry the traffic load as well, traffic loading. So we look at the requirement for the manhole. I think the manhole has to be spaced at 90 meter. Mm, let me see, where is that? The manhole, I think it's yeah, 90 meter for pipelines with diameter less than 750 mm. So 90 meters. But here I will put it more closely spaced because we need to cater for the water from the catch pit. The catch pit probably is will be the spacing will be much less than 90 meter. So maybe about 40 meter in Auckland, 40 or 50 meters. So I need to put it more closely spaced. So yeah, we need to design for the size of the this one stormwater pipe, and then the size of the manhole will be according to the, I think, the size of the stormwater pipe as well. If the stormwater pipe is very big, probably you need a bigger manhole. um there are different materials that can be used for the stormwater pipe. The stormwater pipe, we could use reinforced concrete. We could use PVC, polyvinyl chloride. But we probably the PVC probably, is if it's interior, probably is gray in color. So if we're going to use the UV resistant, so it's called a UPVC. We probably we're going to put it UPVC. So this one, the UPVC, the size is generally generally for up to 375 met, um 375 mm diameter. So if we want to use a UPVC pipes, we have to be less than 375. Okay, I think there are other sizes, to 375, 300, 275 or 250, 225 or 200. So yeah, and also we can use a PE pipe as well. PE pipes, polyethylene pipes, and this one I think we can use up to 450. I think the maximum, um to be double check, I think is about the 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 PE pipe is about 450. 450. um Okay, I think there's somewhere it says that it's for 50. No, not here. The catalog. I think I saw the catalog. It said the maximums. The PE polyethylene pipe is about 450. Need to be checked. Um, and if you want to use more than 475, probably you have to go for the precast concrete, the reinforced concrete. Probably it's a precast concrete, not reinforced concrete. Reinforced concrete means that you have to cast the thing uh, on site. So if you do it at the factory, so that's a precast concrete. So you just get a shop. I think one piece of the pipe, the precast concrete pipe is about 1.5 meter long. So you bring to the site and then join up together. Okay, so So the PVC pipe, if you design for UPVC, that's UV resistant, it can go up to 375 mm diameter. If we want to use the PE pipes, then we can go up to 450. So with these two, I think the UPVC pipe is cheaper, so probably we just use the UPVC pipe for the smaller size. If you are more than 375, then we use the the PE pipes. It's more than, if we have to go um, bigger than 450 mm diameter, then we'll probably have to go for the concrete pipe, which can call quite big, 900 meter and 600 meter wide diameter. Okay, so I think um, the the stormwater pipe, I think we need to um, a certain with certain slope as well. With um, for certain slope, we um, for for our plan. This one is my alternative scheme plan. And then you have another plan. So I think probably something's quite similar for this rod one. This one is at a slope of 1.61%. So the stormwater pipe going to follow this slope, this gradient. Um, one 1.61%, it will become actually 100 divided by 1.61 will give us 62. So 1 in 62. One, that means that one vertical, 62, one, and then 62, one vertical, and then 62 horizontal. And then this the rod 2 is flat. Rod the jaw 1 and jaw 2, they are flat as well. So I'm going to, this one has a much bigger area. Because I'm going to put the stormwater pipe, I'm going to serve this platform and this platform. So this one's going to be bigger. I'm going to um I probably going to use a steeper slope. You could use this one. I can use a 1 in 200. Actually, I could use in 1 in 300. Okay, 1 in 300. Um, I think the Auckland, the council by law, that I think they mentioned about, I think the minimum gradient, minimum slope, I think it's 1 in 1000. But this one I'm going to use 1 in I, 1 in 200. Okay, I showed it the example. 1 in 200. I use a two chart. One is copper white. The other one is the maintenance chart. So they give me similar result. Okay, similar result, but sort of um, there's a little bit of difference. Okay, the speed are quite similar as well. Okay, so the velocity of the water for cell, I think need to be about between 1 and 4 meter. I think it's written somewhere. The the branch line need to be at least 150 a minimum branch line. Okay, I think there's this one 225. Okay, so I think this one depend on the rainfall. If you, yeah, I think um I think I use up to 375. Let me show you. The velocity, I think, has to be between 1, minimum 1, and then um, maximum 4. We don't want the speed of the water to be too fast inside the manhole, especially for the UPVC or the PE. It might cause damage to the joint. So I think the pipe gradient is, I think, 1 in 1000. Um, so this one is a bit, because this one stormwater pipe is quite clean. It's not the sewer. It's not a sewage. So actually it can flow quite well. It's quite clean. But I think but they put it steeper so they can the floor will be bigger. So I think 1 in 1,000 probably is for big area for the I think maybe for bigger pipes. But ours I think I was going to lower it down to like 1 in 200. Also, if your land is too flat, probably you need to have the slope need to be more gentle. If so, our I think you know we have to look at the discharge point and then you go it backwards. Make sure that you have enough cover, um, from enough cover and then enough depth so that that will probably decide the gradient of the slope as well because the I think the minimum depth of the um, let's see the chart. Mm, not inside here. I think the cover of the pipes need to be at least minimum cover 600. Okay, I think um well it's just 1,000 or where specific design show no additional cover is required. Um, about 600 again, minimum 600. Um, so we need to make sure that at all time that the pipe is at least 600 below the surface. Okay. Yep. Okay. So it's cover the materials, the minimum pipe size, minimum pipe size, and then the 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 interval, the spacing of the manhole. Okay. So let's look at the design. I think we need to do the layout of the. So actually, I've done some layout already, but I'm going to just do it again on this. So we need to the space. I think because this is this is a footpath. The hedge part is the one hedge been hedged is the footpath, and this one the the road edge and then the footpath. So this one is you could now you may have this rain garden. So you can put your rain garden in between the along this berm. These are the berm. It's 1 meter wide. You could put so if the rain garden is along there. So our stormwater pipe need to put under the footpath. Okay, so this one probably a bit too near to the lots. We don't want to go into the lots. So probably put under the footpath. Okay. I just do a line. I think I change the layers to stormwater pipe. Is correct. So I just do a line. So I'm going to go into this concrete pipe here. So somewhere around here. I'm going to go all the way up to here. Make sure that yeah, all under the footpath. I need to put. I think just change. Make sure that's okay. Okay, yeah. And then I just put go to this along this footpath as well. Um, I don't need to go to the end. Just here we do. Okay. Um, and this one I'm going to do two. Sorry, just one stormwater pipe. Um, because I want my manhole. This we need a manhole here. We need a manhole to connect to this pipe. But I don't want to put under the traffic loading the manhole. So I think so I need to um oops. I need to oops, let me see. Oh, I need to go catch that one. So something like this. and then I do another one until I think, okay, until I just put the middle. Okay, probably this one I just move a bit. Oops. Let's join this up. Okay, so and so we have need a manhole here at the turn, and then here that I do the same thing as well. I think I probably just copy this one. Copy. Just copy based on this one. Yeah, but like that. Okay. So these are the um these are the stormwater pipe. I need to put a manhole. So the manhole, I think at the moment we're not going to put in the right size. I just put a symbol, the legend. So um so the manhole will be something like um let's copy this. This is a manhole. Just copy this one. Um, these are the legends, and this. Let's copy this legend up. Okay, so I'm going to put a manhole at the um, at the at the intersection of the pipes. So I just copied from the center. I need to put one at the end as well. And okay, the intersection. So all the while, I think I'm not going to introduce any traffic loading for this manhole. Okay. As I said earlier, I think there's that because along the draw or the road to there'll be cache pit, you know, at least two or three cache, maybe two, at least two or three cache pit. This road is about 100 meter long, the road to, so probably about two or maybe two or three cache pit here. So I need to have one more um, this this manhole at the middle. So probably I need another one here as well, one here. So so that the catch is easier for the water to go in. So this pipe here, if it's we just the council the contractor you just need to put a line, you know, the for example, we are not going to draw that. So you need to put a connector here. So for each lots they're going to put here. And for this side, probably they have to put it over here, you know, the connected, so the stormwater pipe from this side, you know, from the gutter, so the water can from the property they can go into the connector and then go into this stormwater pipe. So this one will be the connector pipe. This will be much smaller. So I just type up this one. So yeah, I'm going to introduce a bit more this one, um, this manhole. I think I'm going to put some one in the middle as well. In the middle, and then one in the middle here as well. think somewhere in the middle. Then one in the middle here. One in the middle here as well. And then one in the middle of this drawer one, somewhere here. Maybe I put another one here. Because the rod, they have a lot of this catch pit, so the water from catch pit, you have to discharge into the manhole. So this stormwater pipe will go into the the concrete drain. So I just need to trim let's trim this one. Just I don't like. Okay, just trim the inside one. I can just erase. I don't need to trim. Okay, so I trim. Oops. So yeah, so the inside one you can just erase it. So we introduce all this. I don't want to do everything because otherwise take too long time. So introduce the manhole, and then we need to name the manhole as well. I think we name it. Let's say manhole 1, 2. Okay. Just copy this one. Copy and change it to manhole 1. 1 until starting from 1. MH1. Probably I just bold it. Okay, so I just copy. Okay, just put the things here. Okay, I don't want to take off the snap. Okay, so I just put all this. Need to name each of the manhole. Okay, so starting from this one, let's say 1, and then I change this to 2, this one 3, 4, 5, 6. Oh, let me see. Oh, I got a bit too fast. So this one actually, one. This one should be. I jump over to the next one. Actually, this one's 2. 3, 4, 5. So this is 6. Oh, so I have to redo this again. 7, 8, 9, 10. Okay, so we do everything. um, so we name them, so it be like something like like this. Okay, so all the name from MH1 to MH14. Okay, so yeah, so these are the plan of this one, the stormwater pipe and the manholes. So actually in the like stormwater pipes, if the consultants, they probably have to do the cache pit as well, and then they provide the connector pipes to all the lots. So for our, I think, the student project, I think we just skip that. We don't want to do too detail, okay, because we don't really need to go and apply for like consent from the council. So I think is, yeah, we're not going to go until the consultant standards. So we just make it simpler for us. Okay, so we need to design the size of this pipe. We don't know what's the size of the pipe, so we need to find out the actually I've done some calculation about um, the catchment area, and then the flow. So so for this one, the catchment area, um, I can just put the property. I highlight this. This one is the this catchment here. This one, the Q1. Um, the area is 5756. So the 5756.8. So 5757 square meter. So 1 hectare is equal to 10,000. So 5757 divided by 10,000 give us 0.58 hectare. The runoff, um, runoff property, this is built up area. Um, if it's a fully, the surface is fully like paved, or with cover, I think only little bit of grass verge, grass verge. So that could go up to zero point 0.9. But I think we have a hybrid. Uh, I think we probably have got some people have some rain garden or whatever. And then we so the runoff coefficient will go down to like 0.7. If it's if 0.1, 0.2, we probably only the agricultural land, the fully tilled surface, the ground, the all the most of the water, 90% of the water will go underground. So, but here I think we put 0.7. The rainfall intensity, um, here I just assume to be 90. Um, I think I show you how to get the rainfall intensity. Um, for this one, actually, for this is a primary this is a primary system. Primary system is the stormwater pipe. We have secondary system. Secondary system probably just the rod. The rod serve as a secondary water flow path. So we only design for primary system. Primary system. So and then the the design period we're going to use actually is quite low. Um, primary stormwater system. We're going to design for primary system is 10% AEP. 10%. Um, so it's 10%. That means that 10 divided by 100 is actually is only 10. So that means 10% AEP is actually 1 in 10 years. 1 in 10 years. So it's quite. And for secondary system is 1% is 1 in 100 years AEP. So yeah, 10% actually is one actually 10 divided by 100. So there's 1 in 10. 1 divided by 100 is 0.01, 1 in 100 years. So we're going to look at the 1 in 10 years. Okay, so the it's quite, the standard is not very high. Okay, so let's look at um, Heinz Niwa. We try to see Heinz 4. Okay, Heinz 4. Heinz Niwa. Probably I think uh, because this I'm going to upload to YouTube, so sometimes they'll say there's copyright. I think maybe um, I don't go and look into it. I think I did show it in class before. I think in during the class. So that one from the Heinz Niwa, you look for the chart, and then you you will find that you I think the time of concentration time of concentration is probably is only about, I think, do I have the um I don't have that. I don't have the I think I just show you the example is just the design chart. Okay, so I don't have the Chinese Haniwa. Probably I show you the I think the highway one. I think I got the, let's see, I just quickly, just a minute. I just okay. So this one, the peak discharge, probably this is a peak discharge for the urban area. So it's Q equals CIA divided by 360. So time concentration, so actually they got this formula TC or TE plus TF. So probably it's going to be about let me see there's the Heinz Niwa chart. What is the Heinz Niwa chart? Um, where's the Heinz Niwa chart? Let me just probably at the back. Um, let me see okay here. So this one you go to the Heinz Niwa chart. You can just type in the address, and then that will you should get let me see. I don't have it here. So you can read from the chart. Okay, then for I think around because our land is the land area is quite small, so probably you just look at I think the time of concentration probably about 10 minutes, 10 minutes, and then um this one the average recurrent interval is 1 in 10 years. So you find what is the rainfall intensity. So so probably I assume 90. So some area probably you get about 40, 50. Some area you probably get 100 okay, millimeter per hour. Okay, so the peak discharge, not the peak discharge. Peak discharge, Q for this one Q1 is CIA divided by 360. So we get 0.1 meter cube per second. 0.1 meter cube per second. So and and for Q2 the area is bigger. So this one you get on the area. I think I have to, and then can I click one area, can I click two? So the area is 9271. So okay. So 9271 is a 0.93 hectare. So for this one, the peak discharge is 0.16 meter cube per second. And for the Q3 up here, uh, the area is you click it is 0.44 hectare. The peak discharge is 0.08 meter cube per second. So the flow here, there's not much flow from the left hand side because of valley. So the Q1 will flow along down there, and then this still Q1, and then this Q4 will be equal to Q4 is equal to Q1 plus Q2. So this Q2 is a 0.16, this one Q1 is 0.1, so give us 0.26. And Q5 is equal to Q4 plus Q3. So this one is 0.08, this Q4 is 0.26, that give us 0.34. So we have all the peak discharge from Q1 to Q5. So actually I've done something. First one I use the Colebrook-White formula, and then the other one I use the Manhole formula. Okay, the Manhole formula. Let's look at the Manhole formula. Q1 equal 0.1. I use slope 1 in 200. 1 in 200. And I need to get the velocity for self-cleansing is between 1 and 4. So for this Manhole formula, 0.1, this is the meter cube per second, and then 1 in 200, okay, because my slope is 1 in 200. So I got between 300 and 375. So I will have to choose the big one, 375. So we use 375. Remember the PVC pipe, UPVC, the maximum size that we can use 375. So we choose 375 UPVC pipe, velocity of flow is 0.11. The same one I did with the Colebrook-White. Actually I use 1 in 300. 1 300. The Colebrook-White is discharge in liter per second, so 0.1 is 300, and then the 0.33. So this is the hydraulic radius 0.33, 0.003, 0.05, because you know the 1 in 300 equal to 0.0033. So you just draw this word is upright, so the line goes straight up, and then this one the 300. So from here I follow the line, the slope. This is the slanting slope. This is the velocity. It's about 1, and then the red line is also between 300 and 375. So I think the, the Colebrook-White is more conservative. It's conservative. It should give a bigger. I think it's be smaller value. You see 375. It's actually about close to 375 compared to the yeah, similarly I think is slightly less than 375, but I think this one later on actually see other thing. Some of them I found one is bit different, you know. The For this Q1, Q2 also similar. Q2 also I use 0.16. Q2 also 375 UPVC. Q2 I use 1 in 100 because 1 in 100. Okay, so I also get about less than 375, so I use 375. Because I try to use the UPVC pipe, so I use a steeper slope. So same thing I use for the copper white. So this one, the Manhole formula. This one is 100. Um, this one also about 375. Okay, 375. The speed is about 1.5, 1.6. Okay, so I use 375 UPVC and velocity of flow 1.7. Q3 is about the same for the copper white and the Manhole formula. I think the difference becomes this is the Q4. Q4 is this one Q4, Q4, Q2 plus Q4. So this one um, I use a slope 1 in 62, 1 in 62 or okay. So 1 in 62, the 0.26. So the copper white is 260 liter 260 liter per second, which is 0.26 meter cube per second, and the slope is about 0.2 0.26 sorry 0.016 0.016 okay 0.016 here. So I get 375. I still can get 375, but on the Manhole formula, Manhole chart, I use 0.26. I use the same thing. 1 is 62, which is 0.016. 162 here, and then I use the 0.26 here. But the size, you see, is more than 375. You see, between this green line is between 375 and 450, so I have to use 450. So the Manhole formula actually is bigger, Manhole compared to the copper white. So and this one is 450 as well, 450. So when I use 450, I have to use a PE. I cannot use the UPVC anymore. And the flow is 2 meter, less than 4 is okay. So for the Q5 is 0.34, and the slope is 1 to 60, 1 is 62. So about 60, and then this one is 0.34. So I get about the green line here is near to 450. So I use 450. So the speed is about, I think it's what's that? Between 2 and 2.2. This line is 2, that one is 3, 2.2. Yeah. Whereas for the copper white, um 3.34, 340 liter per second, and then also 0.16. So I get also cost to this is 450. So I have to use between 375 and 450. So I have to use the 450, and the speed is about 2.4 meter per second. So all are the Manhole chart and then the copper white, they're quite similar except for the 0.26, except for the Q4. The Q4, this one, the Manhole chart for Q4 is we have to use the 450 PE. Whereas for the Q4 for the copper white, I can still use the 375 UPVC. Okay, so we know the different size of the pipe. So we know the size of the pipe, for the size of the pipe, for like this is a Q1. So this one is we use the 375 UPVC. This one is Q2. We use 375 UPVC as well. This one, this is Q3, we use 375 UPVC, but this is Q4. Q4, because we got two different answer. By the Cobra is 375 UPVC, but the mains gave us the 450 PE. So probably I'm going to use the 450 PE for this one. The Q2 from this MH7 to MH2, I'm going to use 450 PE, and then this one Q5, I'm going to use 450 PE as well. Okay, so yeah, so um this one will be shown in the, I think in the long section. I I can I can label it on this one as well. I can label it. This one is not fully completed, so I can label this one between the pipe between the manhole. Like this one, this one is 375. Um, so I think I just copy this. So this one is 375 mm UPVC. So I can copy to this one as well, and then this one's 375 UPVC, and then this one's 375 UPVC as well. And then this one also 375 UPVC. So I'm going to rotate it 90. Um, so I'm gonna copy this as well. This one's 375 UPVC. I just copy it up here. I need to label it between the manhole. Not space. I just move it. So this one will be 450, 450 PE polyethylene. Okay. Actually, I can just let me see. I just copy that. I just delete this one. I copy. Okay. So I label the different pipes um, for the for this the stormwater layout plan. And then we also need to do the the long section. Okay, so the long section is uh is slightly different from the rod cross section. Actually, I've done something as already. Um, we we need to identify where are the position of the manhole, the channels, of the changes of the manhole. So we got so many. This is um for the long set for some water pipes along rod one, which is this is a rod one. Okay, actually we need to do the the long section for all the rods. This one along the rod one, rod two, and then jaw one, jaw two. So along the starting from zero here, this one is for concrete pipe, the existing, and then we got MH1, MH2, MH6, MH7, um, MH11, MH12. Okay, so these are the manhole. So um, I find all the I go and use the use the dimension to find the changes. So I just get it from the beginning. So I got all the changes from to the manhole, the middle of the manhole. I got all the changes. So the red one is give me the changes. So I just transfer it into I put it inside here. So um the I identify the actually I do the red line first. You know so all the dimensions I got I just offset from here from the zero and then offset it. So I got all the changes, and then when I got all the changes, and then I just for this rod one I follow the slope, this slope of this the drain. I follow the slope of this rod, this the rod level. Okay, so 1.61%, which is 1 in 62. So I follow the slope of the rod. I follow this on the stormwater pipe. I follow the slope of the rod. So the table, the thing is actually is slightly different. So mine is simplified version. So if it's a follow the consultant, they got more things as well. So I think they got the different other things. They got the hydraulic grade line, um, quite a few more. So and then the existing ground level. So I just simplify just a pad drainage, the gradient and pipe size. So and then the rod level. So the rod level is this line. I don't need to the existing ground level because usually the trench uh, the trench for the pipes, the stormwater pipes, only been dug, you know, when we have the platform already, we have done the work. So then we actually we only need the finished rod level, and then because the platform will be level, and before we dig the trench to for the stormwater pipe and the manhole. So I just need what the rod level, the top of the rod level, and then invert level. So you look at so these are the different the invert level. This um is about 41.72 minus that. It's about slightly less than 2 meter deep. The bottom of the pipe, the invert level of the stormwater pipe to the top of the rod is about um slightly less than 2 meter deep. Okay, so and then this one is the this this go into the drain, the existing drain. Actually, this drain probably is deeper. So I think I put in the control point. Is 39.60. I think I did inside the I think project brief, or I think the control point. The you start with this 39.60. Okay, I think you look at the control point and the project brief as well. All the even for your project as well. So actually this drain is 900 concrete drain. So actually this one probably is not correct. It's deeper. So probably this one the rectangle um okay, I can't this thing is um let me see probably it's deeper. The 900. Probably I think is this drain is quite big. Um, this drain probably is I think because mine is probably something like this. 900. I think 900. It's quite a big drain. The this one is so this pipe is going to um go inside this big concrete drain. Um, and so this one, we just put I I think I put this one as 1 meter. I think the diameter of that the drain, this one, the manhole, I think it's a 1.5 meter, 1.5 diameter. So all of them I put 1.5 diameter. So we identify the position of the manhole based on the channel, and then we just put it there. And then we also need to know um, the junction of because I think this one, for example, this one, later on we could mention, I had to label all this one, MH1, MH2, MH6, MH7. Um, for example, this one's MH2. Um, it's going to join from the MH2. This one is from the drawer one. Okay, so they're going to go join into the MH2. And then for MH7 is from the rod 2. They're going to move the pipe here is going to join to MH7. So we know the level of the MH7 as well. So MH7 here, we know the invert level of MH7. So we can just um, so at least minimum is this 40.9. So the invert level is 40.994, and then we walk backwards based on the gradient. I think rod 2, the gradient is 1 in 100. So you just walk backwards. Okay, so actually I do it. I do the long section in 1 in 1000, horizontally and vertically, and I do this one. Put in the rod level first, and then later on put in the pipe level, and then what I do is that the how to determine I know the rod level because from the previous the rod layout, I know the rod level, and then I just determine the first point here, and then I got the first point, and then I know the slope is same as the rod, so I just do the same slope until the end. Then to find the invert level, I just you just do the dimension. The dimension you do, okay, the dimension from here to here. So it's 19.79 plus the 20, so that give us 39.79. Okay, so that's how we just use the dimension align to find from here to the bottom of the manhole, that gave us the invert level. Okay, so this one is probably is not as the we much simpler than the consultant. Consultant probably have to be more details, but here I think for the academic, for in the institute, I think probably we don't need to achieve that high standard as a consultant. Okay, but if some of you, I know some of a student, they are quite experienced who has been working in the consultant, even do a high standard one. They're all very welcome. So we can just do the industry standards. So we after we finish that, I think I show you earlier how to we need to block this thing, the whole thing, and then uh, because we need to show it in 1 in 200. At the moment, this one is 1 in 1000, both the horizontal and vertically. Uh, so actually, what I just show again. I just I think I copy out something. I copy with the whole thing. So I need to make this block. Okay, so I just draw and block map block. So I need to name the block. Maybe I think B. I got many. So they must sure that the name I put in is haven't used before. I said B H. Need to pick the objects. So I pick all this. Yep, all inside. Yep, I got all inside. Yep, and enter. Pick point. I will pick a point over here that at the beginning of datum. Okay. Convert to block. Yes. Okay. So this is a block now. So now I need to go to the properties, and then I click this block, and then give us the geometry, the scale x, scale y, scale z. This is the y. So if I want to get 1 to 200, I need to blow up the y 5 times. Just put 5. So it should fly up. Yep. So this thing fly up. Okay. So been blown up 5 times the vertically. Okay. Horizontally is still 1 in 1000. So now the 5 times, that means the scale is 1 to 200. So you just you need to, I think you need to explore it first before you can extend the line. So just explore the thing here. Then now you can do the extension. So you extend it. Okay, just extend the line. So yeah, so and then you need to do the labeling to label all this the manhole. What are the manhole? And then you put the jaw 1, jaw rod 2 inside. So and then you have to I think this one probably I made a mistake. No, 1 is 62. So this one should not be. I think the percentage is correct, but it's not throughout. It should be from until 7. I think it's the PE is until this is 7. From manhole 1 to 7 is 450 mm PE, and from manhole 7 to 12 is actually is 375 UPBC. Okay, so this one should be, I just need to label it. What I do is that I just do a dimension linear. Just put it FX. First level, first that one 7, 7. This one. Okay, and then I do another one from here to the end, and here. So I just change it to change the thing. I'm going to specify the slope is gradient. What did I put? I think 1 point gradient. I think I just put the gradient 1.61%, 450 mm PE, polyethylene pipe, or capital letter PE. And then this one is Oops. This one is gradient 1.61%, and this is 375 mm UPVC. Okay, so I think I just change the color, match the properties, anything of this. Okay, so that specify the slope of the stormwater pipe, and then the size. What are the sizes of the pipes? Okay, so yeah, so that's the long section of the stormwater pipe. So we cover the long section, the calculations of the peak discharge, and then to calculate the pipe size using the Coburg White and the Manning's formula, and then we draw the layout plan of the stormwater pipe for this parcel of land. Okay, I think that's all for the stormwater pipe design and drawing. Okay, thank you.